Hey everyone, welcome to Singularity Computers Client Build 11, Part 1. This is going to be a mid-range water-cooled build built into the BitPhoenix Prodigy. I have done a number of Prodigy builds recently, but this one is going to be fairly different because it's going to be almost completely stock standard, although it is going to involve a small amount of modding, and I'm also going to be doing custom cables. So this is going to be more of a practical build. The color scheme is going to be white and red. So I'm now going to get started with a brief overview of all of the components. The case, as I've mentioned, is the BitPhoenix Prodigy, and it's the white version. The motherboard is the Asus Maximus 6 Impact, and I've been really excited about using this board in a build. I have the Intel Core i5 4670K, a Palette GTX 760, 16 GB of Corsair Vengeance Pro, a 120 GB Samsung 840 EVO SSD, and a Silverstone Strider 600 watt power supply. For the water cooling components, for radiators, I have two AlphaCool Nexus, a 240mm ST30 and a 180mm ST45. For the fans, I have a Phobia 180 by 32mm red LED fan and two Noise Blocker PL2s. I have two EK Nickel Plexi CSQ water blocks, an EK Supremacy, and an EK FC670. I have the BitsPower DDC Top Upgrade Kit 250. I'm actually going to be using the 150 in this build. I also have a BitsPower Acrylic DDC Pump Top. So that's most of the components that are going into the build. I'll cover the rest of the components as they arrive. So I'm now going to get started on the build. And as I'm building the system, I'm going to give you a more detailed look at some of the components. The first thing I'm going to do is strip down the case ready for building. Most of you will be familiar with the BitPhoenix Prodigy by now. If not, I'll put a link on the screen to my review. I'm going to remove a number of the components from the case permanently. The 3.5 inch bays, 5.25 inch bay, front panel I/O, and power and reset buttons. Now for a look at the Asus Maximus 6 Impact. This board has been highly anticipated. It's the first Asus ROG ITX motherboard. Recently we've seen other high-end ITX motherboards, but with this board, Asus has solved all of the common problems we see with ITX motherboards. And the problems that have really previously prevented us from using ITX motherboards in high-end builds. Power delivery, high-end sound, features, layout, and heat. If you take a look at all of those aspects on this motherboard, Asus has done an incredible job. This motherboard has the capabilities of a high-end overclocking eATX motherboard, obviously minus the PCIe and memory slots. I'm really excited about using this motherboard in this build. I'm looking forward to doing some overclocking and testing and seeing what this motherboard can do. And hopefully I can use it again coming up in a personal build so that I can really push it to the limits and see what it is capable of, see if it can match up to high-end overclocking eATX motherboards. I've now installed the CPU, the Intel Core i5 4670K, and the CPU water block, the EK Supremacy Clean CSQ Nickel Plexi. This is currently my favorite EK Supremacy. I really like the design. Obviously there's no frosting or circles, it's completely transparent. And it brings me back to the old design before CSQ. This water block is actually the result of EK's ThinkCell. I talked about it in a recent video. I'll put a link in the video description. Now for a look at the memory. This is a 16 GB kit of Corsair Vengeance Pro DDR3. It runs at 1600 MHz, 99924, 1.5 volts. I really like the design of the new heat spreaders. It looks a lot more high quality. It looks like a more expensive kit of memory. It looks like these heat spreaders are a little bit more low profile. I really like the look of them. The main improvement for me is the black PCBs on the memory modules, because the old Corsair Vengeance memory had green PCBs. It was something I always complained about. Overall, I think when it comes to aesthetics, this memory has had a big improvement. So I've now installed the memory, and this is a great looking little config. Now something I'm really excited about is the upcoming release of an EK water block, which basically covers this entire motherboard. It cools the CPU, the power delivery components, and the chipset all in one. BitsPower has actually already released a similar water block, and some of you may be wondering why I'm not using this water block in this build. It's just because when I ordered the components for this build, these two water blocks hadn't yet been released, but it is still a possibility for this build. If you can just imagine that config, the overclocks that would be possible, you could then install a high-end kit of memory, possibly also water-cooled, and a water-cooled Titan or 290X, then overclock the hell out of it and put it into a tiny ITX case. You can see how this starts to become attractive, even for enthusiasts who like to build massive overkill systems. As everything starts to get smaller, if the performance is there, this might be the way people start to go. We're definitely going to start seeing a lot more ITX builds, mainly if manufacturers continue to release motherboards like this. I've installed the motherboard into the case, and it's now time for a look at the SSD and hard drive. So I have here a Samsung 840 EVO 120GB SSD and a Western Digital Blue 1TB 2.5-inch hard drive. They've made some big improvements to the 840 EVO to performance and also a number of other tweaks. It's a great looking SSD. It has a subtle metallic silver paint job with a satin finish. It's also a 7mm SSD. Now, in all of the Prodigy builds that I've done so far, I've used 2.5-inch hard drives. And the reason for this is, if you're going to install a high-end water cooling system into the Prodigy, you really need to remove all of the 3.5-inch bays and also the 5.25-inch bay. So that doesn't really leave you anywhere to mount a 3.5-inch hard drive. Now, you don't have to do this. There is ways around this. You can leave the bays in position, but or some of the bays, but it's just really going to look cluttered. So 2.5-inch hard drives are the best option in this situation because the Prodigy has 5 2.5-inch mounting positions even without all of the bays. Now, I've put a couple of plastic washers between the hard drive and the case just to give it a little bit of breathing space and to stop any possible shorts. Now, moving on to the installation of the graphics card water block. Now, I have two GTX 760s here. One of them is actually for my test bed, and I wanted to use this as an example of something you need to watch out for when purchasing graphics cards you're planning on installing water blocks onto. I was actually going to use this EVGA GTX 760 in this build, but it doesn't have a reference PCB. It has some custom designed PCB which there's no water blocks designed for, so you cannot install a water block onto this graphics card unless it's a universal water block. Now, this palette GTX 760 has a reference design, so I can install water blocks onto it. The interesting thing about the GTX 760 is that it's designed around the same chip as the GTX 670 and 680. So there's two reference PCBs for the GTX 760, the 670 PCB and the 680 PCB. So you can actually choose a graphics card with either one of these PCBs, depending on which one you want to go for the build, which one suits the build. And I went for the 670 PCB because I wanted a shorter graphics card to allow more view to the components, less clutter. I just wanted more of a compact graphics card to suit the rest of the components in the build. But you can also go for the 680 PCB, which I usually would have because I prefer the designs of some of the 680 water blocks that are available from EK. There's actually a 680 water block with the old EK water block design from before CSQ. So you can see I've installed a GTX 670 water block onto this graphics card. It's an EK nickel plexi CSQ. It's now time to install the radiators and fans. So I have here an AlphaCool Nexus 240mm ST30, an AlphaCool Nexus 180mm XT45, two Noise Blocker PL2 120mm fans, and a Phobia G-Silent 18 700 RPM red LED fan. It's a 180mm by 32mm fan. Now for a quick look at the radiators. The quality of these radiators has improved since last time I used them. There's almost no bent over fins. The outer panels look great. They're in perfect condition. They're nice and even. There's no sharp edges or gaps. The paint job is also really good, even finish. And I really like the design of these radiators. They have rounded end tanks, protective plates underneath the mounting holes. The 180mm has multiple inlet and outlet options as well as a drain port. And something that's great to see is that they haven't painted the fins. You can see the copper coming through, and that's going to mean better performance. According to my measurements, the FPI is approximately 14. Great mounting bolts, black nickel for the 240 and copper for the 180. You can see the stickers come separate for the 240. It's just a small touch. It means that you can obviously stick the stickers on yourself so that they're not upside down. So all round, these are great radiators, and one of the really good things about these radiators is that the fluid path is completely copper. So the channels, the end tanks, and this is important because if you have different metals, or even if you have variations in the same metal, you can get something called galvanic corrosion, which is where one metal ends up the anode, the other metal ends up as the cathode. So one metal is positively charged, the other is negatively charged. Particles break off the positively charged metal and attach to the negatively charged metal. So you end up with corrosion in one part of the loop and build up in another part of the loop. So there really is a lot to think about when purchasing radiators. Something else I'm fussy about with radiators is thread size. I don't like anything less than an M4 thread, and most radiators have either M3 or 632 threads. It's not so much that the threads strip, which is often a problem. It's that the bolt heads are almost always too small for the mounting holes in a lot of cases. So the bolt heads go straight through the hole, or they're close to going through the hole, and the strength is not that great, even if you use washers. So I much prefer to use M4 bolts, and I'm now tapping out these threads to M4. You really need to use a drill press for this. You're not going to get the control you need with a hand drill, because as soon as you pop through the hole, the hand drill is just going to go straight down into the radiator and damage it. You do have protective plates underneath the mounting holes on this radiator, so I guess you can get away with using a hand drill if there's protective plates. But it's very easy. All you need to do is drill out the holes to the correct size and tap the threads. So you need preferably a drill press and a tap and die set. And because it's steel, you get nice strong threads. Because the material is thin, it's easy to tap the thread. Now I'm going to have a far stronger configuration, and in my opinion, it's also an improvement in aesthetics. I prefer the look of the larger bolt heads. So just a brief look at the fans. Most of you will be familiar with the Noiseblocker PL2s by now. I often use them in my builds. The specifications are 1400 RPM, 1.269mm H2O, 56.5 CFM and 20 decibels. The specifications of the Phobia G-Silent 18 red LED fan, 700 RPM, 169 cubic meters per hour and 18 decibels. It's a great looking fan with frosted deep red blades, which are going to look amazing when the fan is up and running and the LEDs are on. The cable isn't sleeved, but that's not such a big problem. It's a fairly long cable, close to half a meter. It's a 3-pin fan, and it's 32mm thick, which is going to mean better performance. I've now installed the graphics card and also the fans and radiators. I may not stick with this particular fan and radiator configuration. I'm not happy with the way it looks. The radiators get too close where they meet, and it makes the build look cramped. So I'll probably end up installing the fans on the other side of the radiators and turning one of the radiators around. I've installed grills on the top radiator, and I'm going to remove them because I'm not happy with the way they look. Some of you may be wondering why I haven't installed a 200mm on the front panel. It's because I like to match up my radiator brands, and I wanted to go for Alphacool Nexus radiators just because they had the radiator specifications that I was after. And I didn't really want to go any bigger than a 180mm radiator because I was concerned that it may not fit, it would just make the build look more cramped. And I also, like the available 180mm fans and not so much the 200mm fans. It's now time to assemble the pump and reservoir configuration. Now this BitsPower DDC top has been around for years. BitsPower has now done the same thing with their DDC top that they did with their D5 top. They've made an upgrade kit which allows you to mount a reservoir directly to the pump top. And considering that BitsPower has designed both of these components separately, years apart, they've done an excellent job. You have a couple of different options with both of these components. You can get it in acrylic or acetal. Now the acetal upgrade kit comes obviously still with an acrylic reservoir. It's just the top and base that is acetal. Now the thing about the DDC top upgrade kit is you have to run your loop back to the top of the reservoir. There's no inlet in the pump top itself. And this is actually going to solve the problem that I've mentioned a number of times previously, which is with the D5 configuration, if you run your loop through the pump top itself, it just takes a lot longer to fill your loop. It's not really much of a problem. You know, it's an excellent looking configuration. It's just a small problem with filling your loop. So the pump I've used is the Swiftech MCP35X. I've now put the pump and res config in position approximately where I'm going to be installing it. Now normally what I use for this type of installation is UN brackets. But because I've installed a 180mm radiator, I can't use them. They only come in 120mm and 140mm. So I'm not going to be able to use any kind of stock mounting system to mount this pump and res config. I'm going to have to do some modding and come up with something of my own. So that's the next thing that I'm going to work on here. At this point, I've already been through and got all of the cable lengths, and I'm already starting to work on the custom cables. Anyway, that sums up this part of the build log. Thanks for watching. Please subscribe, like, and favorite if you want to see more.